Hi guys, I'm Ian. Thanks for tuning into the Independent Spirit. I just finished setting up my own off-grid power system here. Snacking on one of Deborah's zucchini muffins as a reward to myself. Figure we'll give you guys a little video on what's involved in a project like this. If you haven't tried the recipe for these, you really should. I'm sure there are a lot of people out there who are hoping or planning to do an off-grid power setup of their own at some point, and it can be pretty intimidating at first if you're just trying to set one up on your own. So we'll go through all the various components here. It is a little intimidating to put together, but they're definitely not all that complicated. So the three main components of an off-grid power system are the solar panels, which are there to create power for you, the batteries, which are there to store the power for when either there's no sun out or it's nighttime, for example, and the inverter, which is there to convert the DC power in the batteries and the DC power from the solar panels into AC, or alternating current, which is what your normal household appliances and lights use. So we'll go over all three of those components one at a time. You'll see this, well, there's some wiring involved. This really isn't all that complicated of a project. Alright, so the first big component is the inverter. In this case, I got a product from Outback Power called FlexPower, where they take an inverter and all of the little ancillary components, they pre-wire it all together for you, get it all set up. That was an amazing time savings, and I would absolutely do it again. I can't recommend that highly enough. There's the complicated part of doing a setup like this is wiring the inverter with disconnects and wiring it to the charge controller, which, like the name says, controls the battery charging. Having this inverter already set up for me was just really great. It allowed me to put this whole system together in about 8 hours, including a fair number of screw-ups. So what you're seeing here, this piece right here with the round-shaped cover, this is actually the inverter itself. It's a 3500 watt inverter at 24 volt. Which means my batteries need to be set up as a 24 volt battery system, and it will produce up to 3500 watts of continuous power. What does that equate to? Well, you kind of have to look at what your various electrical appliances are consuming. In general, 3500 watt is just fine for a moderate small household, which is more than what I'm setting up. So this is almost overkill, which is good. This will take care of any growth in my power consumption that goes on. Next to it, over here, is the second most important component. This is my charge controller. This actually takes power from the solar panels and charges the batteries with it. So it regulates the voltage to be just right to keep the batteries in their best condition. There are a few other little pieces up here. This is what Outback calls a mate. It's just a system status monitor. I can check how much power is coming in, how much is going out, historical trends, information like that. Lets me keep track of how the system's doing and spot any problems that may start to develop. The hub up here is just another of Outback's components to keep track of all the different components that are in the system. That's pretty much it. There are a few raceways down through here. That's where Outback has already wired things like my disconnects. You can see them on the other side of the panel. Allows me to shut off the panels or shut off the batteries. There's a ground fault interrupter in there, and then turn on or off the AC load that goes out to the house. So when I brought this in, I had quite literally 6 wires that I had to connect, and that is 2 going to the house, 3 I guess if you count a ground in there, and that comes out the top, and then 2 wires coming in from the solar panels here. I still need to screw this to the wall, but that'll come. And then 2 wires going to the batteries down here. So, a little nervous putting it together, as you can expect. It's a lot of value of equipment, but went together real quickly once I got comfortable with what I was doing. So you can see the disconnects here that I was talking about earlier. We've got a disconnect for the PV panels, a ground fault interrupter, disconnect for the battery bank and the inverter, and then these are the AC loads going out. This particular system also includes a pair of 120 volt outlets, and that gives me power directly off the inverter, which is useful for me because I don't have this little power shed wired for anything. I've got all my wiring over in the house. So I can just plug something in there. And run it directly off the inverter, which is really cool. It's the first time I've had power here without the noise of a gas generator. So that noise was my charge controller turning on its venting fan. It's bringing in a lot of power right now, and it does that to prevent overheating. So the second major part of any off-grid power system is, of course, the battery bank. You've got to have batteries so that you can continue to have power at night and when the sun goes behind a cloud. And what they do in practice as well is buffer the incoming power, so that your incoming power from the solar panels may fluctuate up and down with sun levels and altitude of the sun, but your inverter actually always draws from the batteries, and that allows it to get a steady charge regardless of what's happening outside. So I have 8 here. These are Rolls Surrettes. They are deep cycle batteries designed for the PV, the renewable energy market. They're really pretty high quality batteries. This isn't something you really want to skimp on unless you want to be replacing batteries every couple years, which I really don't. These are also lead acid, pretty basic technology batteries. There are some maintenance-free, or as we like to call them, maintenance-proof batteries out there. I've lived with a system of those. We all agree they're really not the way to go. These take some maintenance. You do have to check the acid levels a couple times a year. But the good side is when anything starts to go wrong, you can actually fix them. With maintenance-free batteries, if something starts to go bad, you have no recourse at all. So the way these are wired up is in a 24-volt system. So the front row and the back row are each wired together, and then those two are wired in parallel up to the inverter. So I effectively have created 2 24-volt batteries in this system. Each individual box that you see is a 6-volt battery. So you can see we've got a conduit leading out of the battery box and up to the inverter. And they're just 2 leads that connect up to the inverter, a positive and a negative. So the solar panels obviously are the most recognized and really a critical element of a solar power system. This is what actually provides energy in for the batteries and the inverter to use. So I have 6 210 watt panels here. That means they'll produce 210 watts at full power, ideal conditions, which you're really not going to get very often. I'm producing about 90% of that right now. And this is a nice, clear, sunny day. The sun's not quite at the right angle for these at the moment. The way these are wired is actually extremely simple. The connectors that most modern panels come with are called MC4 connectors. And they are, there's a male for positive, a female for negative. They only clip together one way. I designed the string size, or the system size, so that all I have to do is connect all of these panels together, positive to negative, in series. And I end up with 1 pair of leads right here that run into the inverter. And that set is going to be at about 120 volt. Each one of these panels produces about 18 to 20 volts of power in ideal conditions. So they're all strung together, and there's just one line that goes into the power shed to feed the inverter. This is a temporary location for these panels. Once I've got the house bermed, I'll be putting the panels up on the berm behind the house. Right now they're facing kind of southeast. Once I get them up there, I'll be able to point them due south, or solar south. So there you have it. Those are all the components in an off-grid power system. It doesn't seem like a whole lot. It's a little nerve-wracking when you have to plug it all in after you've paid for it all, but that'll let you have power anywhere you want it. Speaking of which, now that I've got power in my house, I'm going to finish off the zucchini muffin here and go work on another project. Thanks for watching.